Any detective worth their badge understands that mysteries are solved with clues. And let's face it, we could be working with millions or even billions of clues. The speed at which these puzzles are solved may be over time or may be needed immediately. So speed matters. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. And to become a well-equipped detective, we will learn how to assemble and orchestrate Spark clusters, decode data with lightning speed, and unravel the secrets hidden within vast data sets. From setting up your Spark cluster to leveraging Spark SQL and more, we'll uncover the techniques that transform raw data into actionable insights over time or in real time. So grab your Data Detective decoder ring, sold separately, and let's crack the case of the great Spark stakeout. Imagine a team of detectives with each member holding a piece of the puzzle, analyzing that piece with lightning speed. That's a cluster. Azure Databricks orchestrates these, launching and managing Spark clusters within your Azure subscription. These clusters, like a well-coordinated task force, process data in parallel across multiple instances, ensuring swift and efficient performance. At the helm is the Spark driver, directing worker nodes to gather and process data from specified sources, all within an intuitive notebook interface. Spark jobs analyze data thoroughly by breaking down complex tasks into manageable units. These jobs are distributed across the cluster's worker nodes, with the jobs further divided into tasks and partitions, ensuring no stone is left unturned. The secret sauce of Spark's performance lies in its parallelism, scaling horizontally by adding nodes as needed. Solving mysteries requires a systematic approach, and Spark's modularity is just that. With libraries like Spark SQL for structured data, Spark ML for machine learning, GraphX for graph processing, and Spark Streaming for real-time data, Spark equips you with a versatile toolkit to tackle any data challenge. Whether you're deciphering complex data relations or making real-time predictions, Spark's libraries provide the necessary arsenal. Compatibility is key in the world of analytics, and Spark's ability to run on various distributed systems and interact with diverse data sources makes it a versatile ally. Whether it's Hadoop Yarn, Apache Mesos, Kubernetes, or its own cluster manager, Spark adapts seamlessly. It reads from and writes to several database and object storage solutions, ensuring that your data, no matter where it resides, is within reach. Creating a Spark cluster in Azure Databricks is like assembling a dedicated team for your investigation. You can tailor the configuration, specifying the cluster mode, the Databricks runtime version, and the types of virtual machines for both driver and worker nodes. With auto-scaling and auto-termination features, Azure Databricks ensures optimal resource management, allowing your team to focus on cracking the case without worrying about the underlying infrastructure. Notebooks in Azure Databricks are the modern detective's notepad, combining code cells with markdown notes for a seamless workflow. You can create new notebooks which result in a .dbc file extension, or import notebooks in several formats, including Jupyter and Python. Whether you're running Python or SQL scripts, or performing interactive analytics sessions, notebooks provide an intuitive interface. Syntax highlighting, code auto-completion, and interactive data visualizations enhance productivity, making it easier to document and share your investigative process. Azure Databricks Notebooks offers robust collaboration features, allowing multiple team members to work simultaneously on the same notebook. Analysts can add comments, share notebooks, and use version control to track changes, making it easy to collaborate and maintain a clear history of edits and updates. Simply attach a cluster to the notebook and start investigating. Now that we have our interface, we can interact. Spark's ability to work with data files in various programming languages, including PySpark, Scala, SQL, and R, ensures that you can leverage your existing programming skills. The DataFrames API a core component of Spark SQL, provides an optimized structure for working with structured data, enabling you to filter, sort, and aggregate data with ease. Whether you're loading data from a CSV file or defining your own schema, Spark DataFrames offer a flexible and powerful solution. Here in this first cell, you can see we're using the spark.read.load chain methods to create a Spark data frame named df. Once we have a data frame, we can view the data using methods like show or display, like in the example. The display method produces an interactive output. Perhaps working with PySpark isn't your forte, and SQL is more your style. From creating database objects in the Spark catalog to querying data with SQL expressions, Spark SQL bridges the gap between code and traditional SQL queries. Temporary views and persisted tables make data accessible for analysis, while the ability to embed SQL expressions in Spark code provides a familiar interface for data analysts. Whether you're using Spark SQL API or running SQL code directly in a notebook, Spark SQL integrates seamlessly into your workflow. Since the Spark SQL API only recognizes SQL-like objects, the data must be in a format that it can recognize. Here in this example, we're converting a Spark data frame into a temporary view named products. So Spark SQL can do its thing, which is what we're performing in the next cell. A native SQL select statement to group and order the data by specified columns in the temporary view. Now myself, I'm a visual learner, so visualizations are important for performing data sanity checks, looking into data statistics, or generating reports. It's a crucial element in data analysis, and Azure Databricks notebooks support built-in charting capabilities. To include a built-in chart as a cell output, you can either perform a SQL query, like shown if using the SQL API, or you can use the display method if using the DataFrames API. When you need more control over your visualizations, Python graphics libraries like matplotlib and Seaborn come to the rescue, allowing you to create detailed and customized charts. These visual tools help you uncover patterns and insights, transforming raw data into compelling stories. It's important to note that custom visualization packages may not work with the Spark DataFrames API. Libraries like matplotlib and Seaborn work with Pandas data frames, so you may need to import those libraries into your session or your cluster. Now that we've talked about working with Apache Spark, let's fire up the DetectoLab 5000 and put these concepts to work in our Databricks workspace. Welcome back, detectives, for another session in the DetectoLab 5000. Now here we're going to be working with the notebook environment in order for us to manipulate data, visualize data, and talk a little bit about the different types of data assets that can be utilized in Databricks notebooks. So first thing, that we're already inside of our workspace, right? So we're inside of our workspace, and what I'm doing is I'm going to open up my transform and visualize using Spark notebook. Now, this was discussed in the last one, but obviously these notebooks need to have compute attached to it. So I'm going to attach the cluster that I created. And you can also see that the default language of this notebook has already been established as Python. Now, how does Databricks do this? Well, whenever a notebook is opened up, it looks at the first code cell that's created and recognizes what code it's in and then sets that as the default for the notebook. Now, you can change languages in here interactively as you go through, but in this case, we'll show you how to do that a little bit later on. Now, there are two different types of cells that you can create in a notebook. One is Markdown, and then one is a code cell. And the code cell can be in different languages: Python, SQL, Scala, or R. And then we have Markdown cells. Markdown cells actually utilize
HTML5. And you can see that when I double click in it, it's actually applying a magic operator to switch the language to Markdown language. The magic operator is what we use to switch languages. And then we're adding our text in here. Since this is HTML5, I could use HTML5 language, like that creates a header value. And then when I come out of here or click outside of it, it'll resolve that to the actual text type it is. So it's creating a header value here. Now, header values might be nice because you can create what's called a table of contents, and it recognizes markdown header values in here. So this is the great thing about notebooks, is that not only can I add really detailed instructions typing these out, and it doesn't get lost in the code like comments do, like this. So it's really great for describing what you're doing or providing instructions, doing things like that. In the code cells, though, to execute a code cell, you can run each cell individually. If you run all the cells in a notebook, right? If we run all the cells, then it will execute these in order, right? It'll start with cell 1 and skip over any markdown cells and execute any code cells that are within the block, but it will always skip over markdown cells. Now, here in this first cell, what we're doing is we're importing some libraries. Now, these are Python native libraries like Pandas, Seaborn, and Matplotlib. We're going to use these packages a little bit later on to make customized visualizations. Typically, what you see whenever code developers develop code using notebooks or whatever, they'll usually import the libraries first. That's usually the first code cell does that. You can also see that there is some IntelliSense that's built into Databricks. Like I can get descriptions of items if I hover over them. I can highlight or click on items and it'll show me every case or highlight every case of what that looks like, or repeats of that particular command in that cell. And it also gives me alerts and things of that nature in the output here. Now, keep in mind that although these libraries or packages may already be installed on the runtime, they're not installed on the session. And that's why we need to import them in here. We need to import these temporarily into the session so the worker nodes have it on them. Same thing with libraries that may not be installed on the runtime. Now, if we install them on the runtime, they're going to persist in there, and then all I would have to do from that point is import what I need, like here. But in this case, this Azure ML Open Datasets package isn't installed on the runtime. But I'm not going to be using it a whole heck of a lot. So why install it permanently on there when I can actually install it in the session itself using a pip install command? So this pip install is just installing the package on here in real time and attaching it to the session. So now I can import the library in and then utilize it. All right. And then the next thing that we're doing is we're importing the taxi data package in, along with a couple of other packages that are going to help us filter down the amount of data that we're going to import, because this taxi data set is huge. So I only want a week's worth of data. And this is what I'm doing here. So if you can see, I'm using this parser package and including a parser method or parse method. Here I'm defining a string value that's a date timestamp. So you can see I'm defining an end date variable and a start date variable that I'm going to apply in a method that's going to pull this data in. So I haven't pulled the data in yet until I execute it. This is what's actually going to pull the data into, and it's in Parquet format. But you can see what I'm doing is in parentheses is typically where we add arguments into a method. So the argument here is the parse is used to create arguments, right? Or just generic values. Here I'm creating a text or string value that just happens to have a date timestamp in here. What I'm going to do is I'm going to use that as the arguments in here to filter down what data I'm bringing in. This last method, what I'm doing is I'm actually converting this TLC variable, now that it's in this Parquet format, I'm converting those into a Spark data frame and saving that as a data frame, a Spark data frame called DF. As a sanity check, I can run a show operation. So show operation is just going to produce a pretty generic output, but this just lets me know that there's actually data in here, right? If I want to see something that's a little bit more comfortable reading as a human, I can use a display method. And display method will produce a rich output. This is where Spark implements that Java element into it. So these outputs are very interactive, meaning it's got tooltips I can hover over. It gives me the column names. It gives me the values in here up to 10,000 rows, right? So there's a lot that I can see. I can also create visuals through here. So from a visualization perspective, I can go into this visualization tool and start creating visuals based on this raw data. Now, this is a raw data frame, but now that it's in a row column format, I can now use XY values to generate visuals in several different ways. So I got several different visualization options to choose from here. I can pick X column values, Y column values, group by operators, and aggregations, and ways to handle null, missing data, and things of that nature. I can even customize the colors for the data and even change data labels or manipulate data labels if I wanted to. So there's plenty that I can do from a visualization perspective. That's one way of working with visualization. So if I want to use native Spark, I can just do a display method, create my own visuals this way, good to go. By the way, once you have created visuals, you can save them, export them out, include them on reports. What I want to do here now is I'm actually going to filter this data set down. Now, if you're more familiar with SQL, then what I'm going to do is I'm going to basically go over the PySpark native SQL functions in here. So you can see we've imported this SQL functions library. And these are things that include like these aliases and selects. Some of this is going to be super aligned with what you would see in SQL, like select, right? In select, we select certain columns. That's what we're doing here, is we're selecting certain columns out of the data frame that we've created. We're also selecting other values and certain characteristics of that. So since our date, we're using a date format method just to pull out the hours of this and saving this as an hour of a day. But I'm using an alias. So an alias is kind of like an as clause in SQL. I'm also using a filter method, which kind of translates into a where clause in SQL. And you can see I'm including and operators in here, greater than, equal to kind of filter out the data. So really, it's just more of a context perspective, right? Or semantics, right? Where I would use select in SQL, I would use select here. Where I would use as in SQL, I'm using alias. Where I would use filter here, I would use where in SQL. Essentially what we've done was we've taken all these filter operators. By the way, we're chaining these methods together using these periods. So I can chain all this together using these periods, right? So I use a period, chain a method, and chaining all these different methods together to formulate this one essential query is what we're Pythonic based query that's going to create this filtered data frame. The other thing I've done here was I've created this, if you notice here, I'm taking that data frame object, and what I'm doing now is using a method called creator replace temp view. Now this is huge, especially for the subsequent step. What I want to point out here is that SQL, if I wanted to use SQL language to query something, SQL doesn't know what a data frame is. It knows what tables are, it knows what views are, but it doesn't know what a data frame is. So in order for us to use native SQL language, in order to query the data that we have, we literally got to create a data object that SQL is going to recognize. So that's what we're doing here. We're creating a temporary view that doesn't get persisted anywhere. It's just attached to the session. So it'll go away as soon as this session is gone or we terminate the cluster. But what I'm doing is I'm creating a view called taxi dataset. Now that I have this view, I can run native SQL language. So you see here, I'm using a magic operator to change the language in this cell. So now I'm telling Spark Engine, hey, I'm using native SQL language now, and I'm using that taxi dataset view in order to perform native SQL statements. And you can see here that I didn't even have to use a display method for this. When I use native Spark SQL in this context, it generates a Java output here. So I can still get a table view and I can still create visualizations using this method as well. Let's take this a step further. Now we're going to further reduce the data set size, right? Or the data frame size. I'm taking that filtered data frame and I'm just going to take 1,000th of what's in that original one. Now, the original one had over 10,000, so I'm assuming it's going to be a little over 1,000 or something like that. And I'm also going to convert this into a pandas data frame. And this is going to be necessary for us to create custom visualizations using Pythonic methods. If I want to use these visualization packages like matplotlib or like Seaborn, again, Pandas and Matplotlib and Seaborn have no idea what a Spark data frame is. It knows what a Pandas data frame is, obviously. So we need to convert it into a Pandas data frame in order to use these Matplotlib packages, Seaborn packages, things like that. So what I'm doing here is I'm creating a visual using Matplotlib techniques. So I'm setting what's called Ax1, and all I'm doing is giving it the kind of visualization that I'm including in here, right? So I'm telling it what data I'm using, the particular column out of that data set, and then I'm telling it what kind of visual I want. In this case, I want a histogram with 25 bins, colored light blue, and then I'm customizing. So I'm giving it a title, I'm giving it an X value, a Y value, and then using the plt.show to actually output the image itself. But that's not all. I can use the Seaborn, which is just a layer placed on top of Matplotlib, for even further customization. They have a lot more color. The color palette's more robust in Seaborn. The visualization types are a little bit more robust in Seaborn. So it gives me a little bit more power to create custom visualizations. Here we're creating a box and whisker plot. So you can see that this is formatted a little bit differently when we use SNS. This one I was identifying the data I'm pulling in. This one, the data is identified in an argument, right? So I'm pulling that in. Setting my X, Y, and title values for this, and then resolving the image. And then finally, we're generating a scatter plot here based on that data. So this is a matplotlib. And again, setting X, Y, title values. And in this case, I'm also setting the access to the plot so I can make this image larger or smaller, or even set the axis for the scatter plot to show up and do things like that. Now, the last thing I want to show you about Databricks, and I believe this is a premium only feature, is this AI assistant. What I'm going to do here is I'm going to add another code sample, and I'm not going to insert any code. This AI assistant that's built into Databricks is going to generate the code for me. What I'm going to do is I'm going to say, can you create, or I'm not even going to say can you, create an interesting relevant visual for the Oh, I don't want it that, right? I want it, no, I do, because I'm going to do it in a matplotlib. We'll copy that. So all I'm doing is that I'm giving it a text prompt here. I'm saying create a relevant visual for that data frame, that pandas data frame that we created. So now you can see that it used Seaborn because I didn't even tell it, right? I didn't tell the AI assistant what it was, but it kind of determined it was a pandas data frame because it looked at it. So it knows it can only use matplotlib or Seaborn. So what did it do? Well, I'm going to run this. I want to see what it did. So this one did something very similar, except that fair amount distribution per passenger account. So it didn't do tip amount distribution per day, but it did use fair amount distribution per passenger count. That's what it considered to be interesting. Now I can continue doing this, and you see, this would have taken me probably 20 minutes to go to the documentation page and figure out how to set all this up for this particular box and whisker plot. But now that I have the base code, I can manipulate it if I want to, or I can continue. Continue or regenerate. Maybe it'll create something else for me. No, and then accept it, and then it'll place it in here. I think that puts a wrap on this particular case. Let's head back into the studio.
As we wrap up our exploration into the world of Spark and its use in Azure Databricks, it's clear that this powerful platform equips us with the ultimate toolkit. From its seamless integration with Azure's robust infrastructure to the modularity provided by Spark's libraries like Spark SQL and Spark Streaming, every component is designed to transform raw data into valuable insights. The parallelism and scalability of Spark clusters, managed effortlessly within Azure Databricks, ensures that no data stone is left unturned. And remember, whether you're a Pythonista leveraging PySpark or a SQLite using the Spark SQL API, the flexibility and compatibility of this platform allows you to bring your existing skills into play. Thanks for joining.